Welcome to your very first video lesson. If at any time you need to, you're more than welcome to pause and rewind this entire segment so that you can get the most out of it. You're going to want to make sure that you have something to write with, on, and that you have your graphic organizer or your note template in order to really utilize all the tools and techniques that this video lesson has to offer. Today's video lesson, we're going to be talking about the scientific method. There are 7 main criteria that you need to hit in order to really understand the scientific process. The first is ask a question. The second is do background research. The third is construct a hypothesis. The fourth one is by doing an experiment that tests your hypothesis. The next one is by analyzing your data that you get from your experiment and then publishing your results. Those are the 7 steps. So the first step is, again, asking a question. When asking a question, you're going to want to keep a couple things in mind. 1, are you interested in the topic that you're asking a question about? And 2, what observations have you made about the natural world in which you are now curious about? Once you have your question, you can go to step 2 of the scientific process, which is do basic background research. In order for you to do your research, you're going to need to use different types of medium. You might use the internet, a textbook, an interview with a teacher, anything that will help you gain background information that will help you answer your question. You're going to want to make sure, though, that your sources are credible. Once you have your question and you've done your background research, it's time to form a hypothesis. Forming a hypothesis is arguably one of the most important steps in the scientific process. It is the backbone for your entire scientific investigation you're about to conduct. It also must be worded in a way that allows it to be testable, meaning you're going to want to avoid saying things such as, I know this is 100% truth or 100% fact. Step 4 is where the fun really begins. This is where you will actually test your hypothesis to see whether you were right or whether you were wrong. This is also where you will start to decide what variables you want to include inside your experiment. There are 2 main types of variables, independent and dependent variables. Independent variables are something that you change in an experiment. Dependent variables are something that is changed because you changed the independent variable. The difference between the two can get kind of confusing at times, so I want you to look at the example on your screen of an independent variable. Say you have 2 plants. One you use water to water, and the other you pour a big old glass of Coca-Cola on. You changing it from water and Coke is your independent variable. Your dependent variable now is the height of which that plant will grow based on what you watered it, whether it was the water or whether it was the Coke. The health of that plant is also affected, so therefore it is also a dependent variable. You might have more dependent variables than you planned on. Usually, the dependent variable is actually what you want to gather data on. So the height of the plant or the health of the plant is actually the data that you're going to use to analyze whether or not your hypothesis was correct. I now want you to look at the example on the right of the controlled variable. This is what you want to stay constant. You do not want this to change. So the amount of liquid that you're watering will never change. The soil that you plant both in will never change. The amount of sunlight both plants get will never change. Those unchanging variables are your constants or your controlled. Once you gather your data, it's time to organize. This is usually done by preparing a spreadsheet or a data table and by graphing your results. Once you've organized your data, it's time to compare results. So if you take our example of the pop that was fed or watered with water compared to pop, you're going to now see how well each one grew. So how tall did the plant that was watered with water grow compared to that with pop? Once you compare your results, you typically record your findings in a written down statement. This brief written down statement should not be confused with your conclusion. In your conclusion is where you will look back at your data and argue either for or against your original hypothesis. If you found that your hypothesis was supported, awesome. If you found that it did not quite fit your hypothesis, you can go back and do another experiment now based off of new data. Your conclusion should be a pretty big chunk of writing that either agrees with and supports your original hypothesis or refutes or disagrees with your original hypothesis. And again, this is based off of data that you found while doing your experiment. Last but certainly not least is publishing our results. The reason why this step is really important is because it goes back to being able to be proven wrong. Once you publish your results, you're saying to everyone else in the scientific community that they can follow either your same procedure to get the same results. And if they can't, they'll refute your original hypothesis, which can cause you to have to redo the entire scientific investigation all over again. So to sum up, there are 7 criteria that are involved with the scientific process. The first one is asking a question, the second one is doing background research, the third one is constructing a hypothesis, the fourth one is creating an experiment that tests the hypothesis, the fourth one is analyzing your data and drawing conclusions, and the very last step is publishing those results. Now, one of the great things about video lessons is, again, that you can go back and re-watch this as many times as you need to. Go ahead and pause it, take notes, make sure that you're getting everything that you possibly can out of this video lesson. Until next time, bye.